In this course, we will be learning about the tools we have available to us for optimizing our app in Unreal. Before we can optimize our project, we have to be able to ask Unreal where the VR project stands in terms of its performance. Things like its frame rate and overall frame time. The Unreal Engine doesn't show this information by default, so we need to first learn about console commands to understand how to find this information out for ourselves. The console is a low-level general system that we can use to query the metrics of the engine while it is running. It works much like Windows command prompt and provides access to diagnostic information. On PC, simply use the tilde key to bring up the console and enter the corresponding commands. On Quest, while connected to your PC with the USB cable and with your app running, open the command prompt and enter the command you see here. This command will send stat unit to your app's UE4 profiling system. The UE4 console system will parse that message and execute function if it matches a function that exists. There are many functions that will retrieve performance metrics from UE4, and that is the focus of this course. Be very careful here. If you have a typo, the system will ignore the command without notifying you why. This command will send stat unit to your app's console. Here are the commands we suggest using. Stat unit. The stat unit command provides frame time information in milliseconds. Frame refers to the total frame time. Game refers to the frame time for the game thread, which can also be called the main thread. Game logic, physics, networking, and blueprints happen on this thread. Draw refers to the frame time for the render thread. GPU refers to the frame time for the GPU to complete one frame worth of operations. If your GPU time is close to the total frame time, and your game thread and render thread times are lower than the total frame time, you are likely to have a GPU bottleneck. Stat unit graph. The stat unit graph is the same as the stat unit metric, but instead of just showing them in text form, it shows them as a graph of those metrics over the preceding 10 seconds. The reason you might want a unit graph instead of a number is because in-game, the frame time is going to oscillate, and the graph lets you see that information depicted visually. Stat FPS. The stat FPS command simply shows the FPS, or frames per second, and the frame time in milliseconds. Notice the relationship that FPS is the inverse of frame time. It is important to communicate performance in terms of frame time rather than FPS because frame time changes linearly, while a change in FPS depends on the current FPS. Thus, it is not possible to tell what a change of 2 FPS means. Stat game. The stat game command is good for game thread related CPU times. Some of the stats occur as part of the blueprint system. Stat engine. The stat engine command is good for seeing the meshed triangle count, frame time, and frame sync time. Frame sync time is the time the game thread spends waiting for the render thread to complete. Stat scene rendering. The stat scene rendering command gives the CPU render thread cost. The total sum of exclusive max should add up to the draw time from stat unit. Stat GPU. The stat GPU command gives the GPU workload cost, which is the cost of all the draw costs and GPU compute operations corresponding to an Unreal Engine system with the given label. This feature is not supported on the Quest because the tile architecture makes accurately assigning durations to individual draw costs impossible. This command gives per pass timings when the project is set to use Vulkan as its graphics API. Profile GPU. The profile GPU command captures the GPU rendering durations, annotated and grouped by its operations and systems the operation belongs to. Pretty fantastic. In the next module, we will be discussing the visualization options for optimization for the Unreal Editor.